These are technologies that scientists have been thinking about that could potentially remove the carbon from the atmosphere. And this is known as geoengineering or climate engineering. So geoengineering is the deliberate large-scale manipulation of the planetary environment to counteract anthropogenic climate change. And this has been out there for about 2 decades now. And it essentially, there are about 27 techniques, and they're divided in 2 groups. One of them directly removes carbon from the environment, and the other one creates reflective measures so that the radiation from the sun doesn't stay in the planet. So there are many different ones that we know of nowadays. None of them have been scientifically rigorously tested, but we've got some that, for example, we can spray seawater near to the ocean, and that will create clouds, and then the clouds are going to reflect the sunlight.
That's seeding. That's seeding the clouds, and that's what happened when Launceston got flooded.
That's exactly what it is.
A couple of years ago, yeah.
It's cloud seeding, so we've got it there.
Seeded.
Yeah. Then we've got foams. So it's almost the same technique, but we create foam and we spray it on the ocean, and then that also same technique reflects the radiation from the sun.
But that's a bad way in a way, because you've flooded Tassie with seeding our clouds.
There are definitely a lot of pros and cons for every technique, and that is why none of them has been carried out to a large scale yet, because they do need a lot of research.
Yeah, yes. That's stackable.
Yeah. Then we've got, most of the techniques that we've got are ocean-based. So we've got carbon storage, where we take carbon from the atmosphere and then they bury it under the ocean or in the sediments. And then we have other techniques for the marine system, so macroalgae cultivation. That means growing algae in the oceans, and then the algae, which are like the plants of the oceans, would take, just like reforestation, they would take up the carbon. So the ones that I mainly know about are the marine techniques, and out of all of them, the one that has been tested the most is iron fertilization, where we have here top left. So iron fertilization is being carried out a few times in the ocean, and what it means is just dumping iron in the oceans. So we know that in the oceans we've got phytoplankton, which is just like the equivalent of the trees or the plants, but in the ocean. They also use water, they use carbon and light and nutrients, and then they use this up to grow, and as a result they produce oxygen and sugar in the water. So in the Southern Ocean, these phytoplankton, they need many nutrients, but there's the one nutrient that is limiting, and that is iron. And we know that from decades ago. But this is the technique that has been the most sort of successful, because you only need a very small amount of iron to make a very large phytoplankton bloom grow. So when phytoplankton grows in the ocean, it looks like this. This image is from NASA, and this is one of the ways of studying phytoplankton. You can see it from the space because they form such large blooms, and they have very distinct color. So with satellites, they can gather images, and that's how we study pretty much how they move and how big they grow. So a few experiments were carried out from the 80s up until now. This is, if you can see, that's Tasmania at the bottom left, near to Australia, and we've got 3 cruises that went down there, and they had a massive tank of iron, and they just started dumping iron into the ocean. And then they tracked how that phytoplankton was growing after them. And 3 other experiments were carried out in the north and near the Pacific. And the reason why these experiments were done in the Southern Ocean and in the north is because these are the 2 regions where iron is a limiting factor. In the other oceans, there are other nutrients that can make phytoplankton grow, and you would need a lot of nitrate or a lot of phosphate to make these blooms grow. But fortunately for the Southern Ocean, you only need a tank. of iron. And these scientists who passed away, called John Martin, started the whole theory of the iron fertilization project. He said in 1988, have a tanker of iron and I'll give you an ice age, because he knew back then that with just a little bit of iron he could make a large phytoplankton bloom grow, and he knew that phytoplankton was capable of absorbing this carbon from the atmosphere. And from then, many different scientists have been trying to prove this technique. Obviously, there are a lot of pros and cons of adjusting the environment like this, but that is why geoengineering is just at a very early stage, and there are definitely a lot of approaches that we should look into. But I think that together with changing lifestyle, geoengineering can make a difference to limit the warming and counteract climate change.
Thanks, Clara.